All right, mic check. I feel like it's been a while since I've done this. All right. I think the music's at an adequate volume. I hope. Anyway, let's go through this. So this is the Cambridge Maths paper. It's 2020. Don't really. It's like the Cambridge textbook made their own paper, so that's kind of cool, I guess. How do I have a viewer? I swear this is private. And they're gone. Anyway, all good, all set up. Now the paper actually doesn't have lines, so I'm going to have the paper on the left there, and I'm just going to use like my own lines when it comes to those questions. But for the multiple choice, we should be good. And I guess we'll just call this part one. So multiple choice. What will investment of that be worth in 5? So we've got, that's our starting present value. That's our rate, so our years, sorry, that's our rate. Now the fact that it's compounding monthly means that it's going to be, so my future value would be 50,000. And then 1 plus, now 6%, but it's compounded monthly, so I'll divide by 12 and times by 12. That's 5. When you track that in your calculator, you get that. Which statement is true about the point? Okay, so it's talking about the first and second derivatives. So the first derivative, if we look at this, I'm going to draw a tangent on there. It's got a positive gradient. So that means the first derivative, I hate that notation, but whatever, that's got to be positive, and it's, so looking at this, it's concave down, which tells me the second derivative is negative. So it's this one, let's see. On the screen, yeah. The results of an English exam were normally distributed, the mean and standard deviation were that and that respectively. Okay, that's their Z score. So Z is equal to, oh no, what's the Z score formula? Keep in mind that's on your reference sheet. X minus mu on sigma. Okay, get rid of that. So that's that. X is the score, so I don't know what that is. I know the Z score is negative 1.5. So X is what I'm trying to find. And mu is the mean, which is 63, and that is 16. Okay, so then on this side I've got minus 1.5 times by 16 plus 63. That's what X is going to be. When I type all that into the calculator, minus 1.5, 16 plus 63, 39. 39. Seems right. Cool. Now you can just do a quick check. You know his Z score is less than the mean. The mean is 63. So 1.5 or less than that would be, what's 16 plus 8? 24. So you just got to take 24 from that, really. But same thing. Okay. Next question. So that's that. Okay. The line has an equation. Tells you M. No, it doesn't tell you M. Acute angle. Okay. Let's just rearrange this so it's in point gradient form. So 2y equals minus x minus 3. Y equals minus 2 on 3x minus, that's wrong, what am I writing? Minus 1/2 x 3 on 2. Okay. My gradient is, so m is less than 0 because it's negative. So it's not that and it's not that. Is my gradient bigger, sorry, is my angle bigger than 45? So you can do the old m equals 10 theta. But you really don't need that. If you just draw the quickest sketch in the universe, if it's got a gradient of negative 1.5, that looks like this. No, less than that. So remember that that's a gradient of 1. 1/2 will be like that. That's actually going the other way. It's actually going the other way. It's just going to be like that. Saying is theta less than or greater than to 45. Now, it's the acute angle between L and the x-axis. That's where people are going to stuff this up. Let's get rid of that and that. So even though this is bigger than 45, it wants the acute angle here, which is going to be less than 45. So less than 45, it's going to be a D. If the primitive is that, which statement is true? If that is the primitive. Oh, easy. So when I differentiate, holy moly, what's the going here? The primitive. Yeah, so you go from f of x to capital F of x. So it's not that or that. So if I integrate this, I should get this. So if I integrate this, I should get, yeah, so it's either one of these two, and then it's whether or not you do this one first or this one first. And I guess that just comes down to a knowledge of integration. That's just B, which expression is equal to this. There's a quick way, well, not a quick way of doing this. If you weren't confident in trying to rearrange this, what you could do is just chuck some random value in here, probably like 30 or 45 or something. Something that might give you a nice number, and just like cross-reference it with the answers to each of these and see if they're the same. Or you just recognize that sec is the same as 1 on cos, which means that's sine on cos, which is 10. Okay, consider a point on a curve. Let's pretend I've got a curve. If the first derivative is equal to 0, what does that mean? Well, that actually means it's a stationary point, and the first derivative is positive on both sides. So if it's positive on both sides, it means it's both increasing on both sides. So increasing and increasing, but it is stationary. So that means a point of inflection, it's one of these two. A horizontal point of inflection means one that actually stops. So you know those random points of inflection that are like when it goes like this. There's a point of inflection, but that's a horizontal point of inflection where it actually stops, whereas this one doesn't actually stop. So it's this one here. Coolsies. All right. A displacement time graph. Okay, this one's kind of cool. It relies on a little bit of knowledge of calculus, but not too much. Displacement time graph. Now, I guess the thing you need to realize is it wants the velocity and it's given you displacement. So there's two things you can do. First one, displacement is, when you differentiate displacement, you get velocity. So I could come up with an equation for this, like f of t or whatever, and differentiate it. But you just need, I guess, like if you think of, yes, that is the derivative, what does that mean in terms of the graph? Well, if that's the original graph, when you differentiate a graph, you're finding the gradient function. So really all I need to do is find the gradient of this line. Now the gradient of a line is just rise over run. So that's going to be the rise 15 over the run 5, which is going to be 3. That's it. So just comes to an understanding of straight lines and a little bit of calculus. What's the gradient of the tangent to the curve at its y-intercept? Ooh, oakley dokley. Does that mean that's a couple of things? I need to find the y-intercept. That's a cool question. I guess we could draw that too. It's a cubic, except it's moved to the right too. 1, 2. So it's a matter of what this point is. I don't really know what that is. So y-intercept make x equals 0. So y equals 0 minus 2 cubed. I know that's minus 8, so there's minus 8. So that's what I'm trying to find. Now I've got to integrate it. So, sorry, differentiate it. dy dx. It's going to be, I'm going to use a chain rule. So that, then drop it, and then at minus 8 minus 2, 2, that's 3 times minus 10 squared. That's going to be 300. That's it. So is that the point? What's the gradient of tangent? That's not the answer that they've got, so I'm a little bit concerned with the gradient of the curve. What have I done wrong? Times it by the derivative. Substituted minus 8. Did move to the right, didn't I? Put a 0 in there, that's minus 2 cubed, minus 8. Put minus 8 into there. Oh, I don't know why that's not 300. I'm pretty convinced that it is 300. I don't know, the answer has something different, but I'm not really convinced. I reckon it's 12. Oh well, I'm pretty happy with my working. Minus 8 minus 2, yeah, okay. Oh well, I guess I would have got that wrong. Which function is a primitive of this? Okay, so the easiest thing to do, instead of trying to integrate this, you could just try and differentiate each of these. But I guess if you recognize that the derivative is kind of out the front here, I just kind of play with this and see what works. So maybe I'll just go with this one. If I differentiated that, I differentiated this, I'd end up with an x squared. That's not what I want, I only have an x. So I think it's this one, because if I differentiate that, I've got 2x times a half e to the x squared. So I brought this down here, the derivative of it. So I differentiated it. So then these go. So that's just x, e to the x squared. So it's that one, it's a. Okay, cool. Now we get to our actual questions. This is where I want to have them on the screen. Have it so that it actually says question 11. Cool, whatever, that'll do, I guess. Okay, so I'm going to have to add some pages. Okay, so this is actually what you'd have to do in your exam. Question 11. A. Right. What is the median height? Well, let's go back over here. Median is going to be the thing in the middle. This is literally how I do median questions. Boom, boom. So it's here, it's in between those. It's 184.5. So 184.5. B. Find Q1 and hence the interquartile range. Okay. Q1 and Q3. So that there's going to be Q1. That's going to be Q3. And QR, maybe I should write these. Q1, what did I just say that was? 183. Q2 is 187. Not Q2, Q3. That means IQR is Q3 minus Q1, which is going to be 4. All right. Okay. C. What does it say? Draw a box plot of the given data. Cool. Well, this doesn't need to be to scale, so just draw like a. Jesus, that was terrible. That was also terrible. What am I trying to do? I want. What's the minimum? Minimum is 178, so let's put 178 on there. The maximum is 198. 198. What's the median? 184, so that's around here. 4.5. 183. Maybe here. 187. It's probably a little bit further. 187. Now draw a box plot. I need to move that over a bit. Draw my little whiskers. That's terrible. That's good. I need my line. There we go. Okay. D. I like that D. Determine whether there are any outliers amongst them. Okay, so that's nice. Actually gives me the equation for outliers. So let's go with the first one. It's Q1 minus 1.5 IQR. Okay, that's equal to 183 minus 1.5 times 4. That's equal to, oops, I've got the answers here. It's equal to 177. Okay, so there's no lower outliers because 178 is the lowest. Then what's the other one? Q3 plus 1.5 IQR. So that's 187 plus 1.5 times 4. That's equal to 193. So 198 is an outlier. Is there anything else? What's the data? 190, 198. Okay, so therefore 198 is an outlier. Cool. That's question 11. Question 12. Lucas has opened an investment account. Good on Lucas. He will invest $80 at the end of each month for 4 years. Okay. At that rate, with interest compounded monthly, he wants the future value of the account to be that. The future value of, well, they've already told us that. Isn't that nice? Future value of $1 is that. Find A. That seems too easy for 2 marks. Future value of 1. So, future value on $1 is, what is it, 54.0978. So then the future value on who will invest $8 on $8 is going to be A times that. Yeah, that makes sense, doesn't it? It's a weirdo. Okay. And that's going to be equal to, so it says the future value is that much. Oh, that's equal to 250,000. I've literally got a one-step equation here. A equals 25. That's approximately 2, according to the top of my head. Cool. That one was nice. Question 13. I wonder if we can hear the vibrations. How popular I am. Oh, Zoom in 10 minutes. Oops. Gonna miss that. Cosine rule. Easy. Let me draw the triangle. No, let's not draw the triangle. Cosine rule, I need an... Okay, so this 45 is going to be... Yeah, I'm just going to draw the triangle. Without trying to explain it. Oops. Okay, that's going to be 45. 3 root 2, 7x. So that's going to be C, A, B. So what I'm trying to find x. So it's C squared equals A squared plus B squared minus 2AB cos C. Okay, that's 9 times 2 is 18 plus 49 minus, that's, okay, 14 times 3, or 6 times 7 is 42 root 2. Cos 45 is a half? No, root 2 on, 1 on root 2. Or root 2 on 2. 1 on root 2 is nice because they're cancelled. They're going to go. So now I've got 18. Let's try and do this in my head. 18 plus 49 minus 42. That there is 7. So 18 plus 7 is 25. Ah, look at this. No way. X equals 5. Is it actually that nice? Oh, it is. Yeah, right. Okay. 14. Take a new page. Okay. Down. Right, consider the triangle with ABC. Let's just draw the thing there. Is it right angled? No. Oh, 2 possible sizes. Okay, so there's an acute and an obtuse one. So let's draw 2 triangles. An obtuse one and an acute one. Hello. Alright. ABC. AB is, so hang on. BAC is 30. Let's chuck 30 here. Here. Possible size of AC. So that's going to be C. So let's just call that theta. What is it? A? No, it doesn't matter where A and B are, does it? A and B. And actually it kind of does because they're fixed. Screw it. AB is 20. And BC is 15. Looks like sine rule from observation, because I can do this. Okay, 2 possible sizes. Cool. All right, let's call, okay, so I'm trying to find an angle, so I'll go sine theta on 20 equals sine 30 on 15. Sine theta equals, now sine 30 is a half, so it's going to be 1/2 times 20 on 15, which is going to be 10 on 15, which is going to be, just going to be 2 on 3. So then theta 2 on, Okay, that's approximately equal to, let's just do it. Make sure I'm in degrees. Okay, 42. 42 degrees, but it could also be 180 minus that. 138. So 42 or 138. They're my two possible angles. What was it? Angle ACB. Cool. That was 14. Now 15's got multiple parts. Okay. Solve the equation. Well, x minus 2 equals 2. Okay. That means x minus 2 equals either positive 2 or negative 2. So that means x equals positive 2 or negative 2 plus 2. Oops. So that means it equals either 4 or 0. Seems like it to me. Sketch that and that on the same normal plane, clearly indicating the coordinates of the points of intersection. Okay, well, we've already found the points of intersection, so that's cool. B is going to be, so let's just draw this. Okay, that is just x minus 2. So x minus 2 is a graph that looks like that. Now, since it's the absolute value of that, this part's going to pop up and be like this. So it's going to be like that. That point there is going to be 2. So that's y equals that. Y equals 2 is just going to be a straight line that cuts at 2. Is that intersection going to be 0? Yes. Okay, so that there is point 0, 2. And I know that it cuts there because of this. That means this point here is 4. There's all the coordinates of the intersection. Yeah, indicating the coordinates of the points of intersection. Okay, so when x equals 4, y equals, well, that's a 4, 4 minus 2 is 2. So, okay, so that's just, wait, what? That doesn't make any sense. When I put 4 in here, 4 minus 2 is, how can this be 2? Excuse me? Oh, the y value is 2. You idiot. Of course, 2 doesn't, that makes complete sense because it's there. You numpty. Okay, 3. Sadly. Wow, losing it. Hence, solve x minus 2. Okay, I'm going to do some blue. X minus 2. Is it greater than or equal to 2? Okay, so basically, when is this graph bigger than this graph? So when is this graph bigger than this graph? Well, that's up here, yeah, which means it's all of this. So let me actually draw that. That's all of this and this. So when I have to do this in advanced notation. So when negative infinity to x to 0 union negative, no, that needs to be equals 4x infinity. Okay, so this one says from negative infinity to 0, so negative infinity to 0. This one says from 4 to infinity, from 4 to infinity. Right, actually I have to think about that. It was a little bit annoying. Why don't I just write it in the normal notation? Why don't I just write when x is less than 0 and when x is greater than 4? I could have just written that. I don't know why I didn't. Oh well. Is that's hard to see on? Yeah. I'm going to question 17 for this first part. How many minutes am I up to? 24. Flying through this. 16. I like that, 16. A new car depreciates in value by that percentage. Okay. How long will it take for the car's value to fall below 20%? Okay. A new car So it doesn't tell us what the price of the car is. So let's let that equal something. Is this more? No. Okay, so value of the car, V. Now what happens to it? It's depreciating, so it's 1 minus. It's 13.5%. I think I appreciate time. Okay, so 13.5%. I don't like it written like that, so let's just go 0.135. Okay. Does it tell me how long? How long is what I'm trying to find? Okay, and I want to know when that's equal to 20% of the original. So when it's 0.2 of the original. Okay, so that's my equation. I've just set up my equation. These can go. And then I'm going to have to take a log, aren't I? Let me just tidy this left-hand side up. 1 minus 1. I'm going to have to. 1 minus 0.135 is. After 1 is a decimal. Yeah. 0.865 to the power of n equals 0.2. Okay. So then log or ln 0.865. N comes out the front. Ln 0.2. N equals ln 0.865 or ln 0.2. Okay. Ln. I just wrote log. Oh, it doesn't matter, does it? 0.8. Log 0.2. That's around about. I feel like that's not quite right. What have I done? I've written this upside down. I was going to say I've got 0.09 also. That doesn't seem right. That would be why. 0.865. That seems better. 11 point. What does it want to do? Your answer as a whole number of years. Okay, well, let's just write we've got 0. That. Okay, so n approximately. What should we call that? 11? Appreciates? Do we want to round up or down? How long does it take for it to fall below 20%? Okay, well, when it's after 11 years, it's not going to quite get there, is it? It's still got a 0.9 to go, so let's call this 12. I'll round up. Okay, that was 16. 17. New page, eh? 17. Okay. Last question. Determine the value of k. Oh, I like these questions. Okay, so these just have to add up to 1, the bottom ones. I believe that's as far as we go. So 0.3 plus k plus 2k plus 0.1 just needs to equal 1. Okay, well that's 3k plus 0.4 equals 1. 3k equals, what's 1 minus 0.4? 0.6. K equals 0.2. Seems legit. Calculate EX. Okay, well, EX, and this is on your reference sheet as well, is the sum of x px, which means I just add each of the values in the table. So x px, so 0 times, so the score times the probability, 0.3, plus 2 times k is 0.2, plus 5 times now 2k, so 2 times 0.2, plus 9 times 0.1. I'll chuckle that to the calculator. Let's just do that. The first one's obviously negligible, that's 0.4. Plus 5 times 2 times 0.2 is 0.4, plus 0.9. I've got 3.3. Expected value is 3.3. Cool. Done. Beat half an hour. Look at that. Smashing this. Right. Stop there. Part 1.